Polymers are everywhere. Everything in this photo is comprised of polymers. Today, I'm going to talk about PVA glue. As surprising as it might be, PVA glue is very much a polymer. Invented in 1912 by Fritz Clatter as a wood glue, it is a common and therefore easily visualized polymer. White PVA glue is a mixture of about 40% water and 50% polyvinyl acetate. The other 10% is mostly unimportant for what we're discussing. It is an emulsion, which means that it is small droplets of PVA suspended in water. Once this water evaporates, the droplets come together to form the clear glue. Later, I will talk about how glues work. But first, let's talk a little about polymers in general. Polymers, as you know, are composed of individual monomer units. These can grow in two main ways. First is called step growth polymerization, in which the monomers themselves can react with each other. First, the monomers will form dimers, comprised of two monomers, and then trimers, made of three monomers, and so on, until eventually these individual chains will join up to each other and form the longer chains, typical of polymers. The second way polymers can grow is called chain growth. The monomers can't react with each other, so to make the chain grow, we first must introduce another chemical called the initiator. This chemical reacts with one monomer, making that monomer reactive to the other monomers in turn. This process will continue until all the monomers are added to the chain. If we have two initiators, there will be two chains formed. These will grow at the same rate until all monomers are used up. However, now there are two chains, it is possible for the chains themselves to combine and stop each other growing, meaning the chain will be stuck at this length with unreacted monomer still in solution. For each molecule of initiator we add, we will form that number of chains. Here, we are back to one chain. This chain is growing nicely, but now in with the monomer is an impurity. This impurity, once added to the chain, will stop it from being able to grow any further. This can help us control the length of polymer we create by introducing it at a set point, but it can also sabotage the growth of our chain, stopping the formation of what we are trying to create. By choosing the monomer and initiator we use, we can create the polymer chain to either have electrophilic or nucleophilic ends. These will react with the monomers and add them to the chain. The monomers are incapable of reacting themselves, but with the introduction of an initiator, we can cause them to react. A can be our initiator. The electrophilic addition of A onto the monomer will create a carbocation on this carbon. This can then electrophilically add to another monomer to continue chain growth. This process is called cationic polymerization due to the cation being formed on the monomer. Anionic polymerization is also possible and more common. PVA is made from vinyl acetate monomers. These are polymerized by a process known as free radical polymerization, the third and final method of chain growth polymerization. In the industrial synthesis of PVA glue, potassium persulfate is commonly used as an initiator. This, when heated, will break down to form two sulfate radicals. These will then attack the double bond in the vinyl acetate molecule, generating an initiator monomer radical. This will then attack another monomer, growing the chain. This radical attack will continue until another radical joins the end of the chain, stopping the growth of the chain in a process known as termination. AIBN is also a common initiator. This works in much the same way as the potassium persulfate. For the synthesis of PVA, methanol is used as a solvent. The purpose of the solvent is to hold the monomers and growing chain in suspension so they can easily collide with each other and react. Going on now to talk about the principles of adhesives. There are two main forces which are needed for a good adhesive. The first is the cohesive force. This is the force which holds the material together. Metal, whilst not sticky, is particularly good at holding itself together. You can't easily break metal apart. The second force is the adhesive force. This is how sticky the substance is, how good it is at attaching itself to another material. Both the cohesive and adhesive force are controlled by the strength of the intermolecular interactions between the material itself and the glue and the material it's gluing. Adhesion and cohesion are exclusive of each other. Honey is very sticky, but if two things were stuck together with honey, they would be easily pulled apart. Therefore, for your glue, you want a material that holds onto itself as well as holding onto what you are trying to glue together. PVA, like all glues, is a mixture of a solvent and a polymer. The solvent not only stops the glue from drying in the bottle, but also helps the glue to enter the pores of the material it's trying to glue. Once the solvent has evaporated off, the droplets of polymer come together and harden into their plasticky form. They then hold the things you are gluing together better as they are inside the pores, allowing for strong adhesion as there is a greater surface area. Also, to separate the glued material, you'd have to remove the glue from the pores, which is not easily done. Another interesting property of polymers is that they have two distinct phases whilst solid. The first is the glassy state, where the polymer is brittle and easily broken apart, like chocolate. This property is due to the chains not being able to move over each other and deform. Instead, they just break. The second phase is the rubbery phase, where the polymer is elastic. The chains now have enough energy to move over to each other, allowing for some deformation. Upon further heating, the polymer will melt, and once melted, it will behave a lot like a liquid. Here, I have PVA in its glassy state, below 30 degrees centigrade. As you can see, it snaps apart. Here, at 45 centigrade, I have my PVA in the rubbery state. Here, it behaves like chewing gum. Thank you for watching.